Good morning, students. Today we will have our discussion there on very simple topic, that is encoder. Now, what is a encoder? It is basically a combinational circuit that encodes the information from 2 raised to power n input lines into a n-bit code. So in other words, what we can say, the information available over the input lines that would generate a code over n output lines. So that's why it is basically the reverse of a decoder in functioning. So from the definition, now it is very well cleared that it will have maximum 2 raised to power n input lines, and corresponding to those 2 raised to power n input lines, we will have n output lines. Now, what is the block diagram? It is very simple. Here we will have the input lines, that is 2 raised to power n, which will utilize n output lines. So if 4 input lines are there, then the output lines will be 2. Now, what are its types? There are some common types we basically consider there in the designing of encoder. So they are 4 to 2 encoder, 8 to 3 encoder, as well as some special types, that is priority encoder and decimal to BCD encoder. Now let us start designing, or let us start learning how we can design a 4 to 2 encoder in digital electronics. Now 4 to 2 mean here there will be 4 inputs. Let us say they are used here with symbols y0, y1, y2 and y3, and corresponding to these 4 input lines we will have 2 output lines, let us say A0 and A1. So what the definition says here, or what 4 to 2 encoder as far as its working is concerned, so we know that among these 4 input lines, one line will be active at a time, and that line will give the respective binary code on the output lines. So one input line is active at a time to get the respective binary code on the output lines. So this is the main core of this 4 to 2 encoder. So just like the journal block diagram, one can simply design the block diagram of either 4 by 2 or 8 by 3 very simply. So you can see here in this block diagram we are having 4 input lines, and corresponding to these 4 input lines we are having 2 output lines. They are, let us say, they are represented in terms of A0 and A1 symbols. So corresponding to 4 input lines y0, y1, y2 and y3, we are having two outputs lines, let us say a0 and a1. So in this 4x2 encoder, only one input line will be active at a time, which will generate or which will give a n-bit code over a0 and a1 lines. Now what is the truth table for this 4x2 encoder? Now just remember, we are having four inputs. Let us say they are represented such as per the block diagram, y0, y1, y2 and y3. As we know from the definition, one line will be active at a time. So you can see, if we talk about this particular row here, the y0 input line is active, which will generate the code over a0 and a1. So the code is 00. Similarly, if we talk about the second row, the y1 line will be active by keeping other lines disable. That is y0 disable, y2 disable and y3 disable. And the code is again over the two output lines, that is a0 and a1 is 0 and 1. Similarly, the rest of the two entries there in the truth table, which will keep y2 active as well as y3 active, results to two other codes, that is 1 0 1 1, again over the output lines a0 and a1. So what we mean here, you can see from the truth table, at a time one input line is active, which generates a binary code over the output lines a0 and a1. Now next thing is how to write the logical expression for this 4x2 encoder. Now you can see here, following this truth table, if we follow this truth table, then we can see here, if we talk about the very first row, or if we talk about, let us say, the output variables a0 and a1. Now the first variable, if we talk about this particular column a0, now just observe in which rows the a0 is high. High mean in which rows the value of a0 is 1. So you can see here, it is high here, it is high here. So corresponding to these high values, let us observe which input variable is basically making it high value. So you can see a0 is active or a0 is high there over two rows, or in two cases it is basically active, and those are with y1 variable and y3 variable. So you can see here, when the expression of a0 has to be written 1, then the corresponding inputs we found there are y3 and y1. They were active, which results to A0, that is active or high value. Similarly, if we talk about the second variable A1, let us go back to again the truth table to observe how this A1 or what lines or what input lines they are utilized there in writing the logical expression for A1. Now you can see A1, just like the previous case, observe this column, it is active here, it is active here, or it is a high in these two rows. So corresponding to these two high values, let us observe the inputs. So the first input is y2, and in the second case y3. So corresponding to these input lines, the expected output A1 is high. So now we can write, just like the A0, we can write the Boolean expression or the logical expression for A1 there. So it means that A1 output variable now is based upon y3 and y2. So that's why these two output variables of A1 and A0, they utilize the inputs y1, y2 and y3 here. So it is very simple to learn. It is very simple. One can simply understand with respect to the truth table why we can write the logical expression like this. Now the logical circuit. Now logical circuit, as per this logical expression, you can see here, ending between, if we implement A0 line in terms of circuit implementation, then it is basically utilizing two variables y1 and y3. You can see here A0, it is A0. So it is utilizing y1 and the second input here, that is y3. So you know we are having here, that is OR. Similarly, if we talk about A1, then it is basically utilizing y2 and y3 variable. So y2 and y3 again, so these are the, so y3 and y2 with this OR results to A1. So it is it is not a difficult one. One can simply learn the truth table, or from the definition even it is very clear that by keeping one input line active at a time, we will get the corresponding code over the output lines. So this is basically about the 4 to 2 line encoder. Now the next part of discussion is how one can design 8x3 encoder. Now 8x3 encoder, basically again from the definition, we are having 8 inputs. Let us say they are represented as y0 to y7, and 3 output lines, let us say represented as a0 to a2. So just like 4x2, among 8 input lines, one input line will be active at a time to get the respective binary code on the output lines. This 8x3 encoder is basically known as octal to binary encoder. Octal to binary mean that we are having 8 input lines, and corresponding to those 8 input lines we are having 3 output lines, which basically gives a binary code over A0, A1 and A2 lines. Now the block diagram again very simple. We are having 8 inputs and the 3 output lines. So these 3 input lines, these 3 output lines A0, A1, A2 will generate a code depending upon the input line active at a particular time. Now the truth table. If we talk about the truth table of this 8 by 3 line encoder, then just like 4 by 2, one can simply write or one can simply learn, but the basic concept that one should know is we have to keep one line, one input line active at a time, which will results a binary code that is available over the output lines A0, A1 and A2. So if we talk about the very first row here, you can see in very first row we are keeping Y0, or Y0 line is active and rest of the lines they are totally disabled, which results to a code 0, 0, 0 over the output lines A0, A1 and A2. Similarly, second row that will keep Y1 active and rest of the lines disable 1, results to the code 0, 0 and 1. So one can simply learn this truth table, or one can simply draw this truth table by keeping all the inputs active with respect to the corresponding rows. Now, how to write the logical expression? So you can see here we are having from the truth table 3 output variables A0, A1 and A2. So we have to write the logic expression, or one can simply write the logic expression for these 3 output variables just by observing the truth table. You can see the first output variable is A0. Now if we talk about the A0, just like 4 by 2, observe the outputs when it was high. So you can see here it is high, A0 is high here, it is high here, it is high here, it is high here. So it means that 4 times it is high, and let us observe it was high in or with respect to which input line. So this high corresponding to Y1, this high corresponding to Y3, this high corresponding to Y5, this high corresponding to Y7. So it means that now A0 will utilize the variables Y1, Y3, Y5 and Y7. Similarly, if we talk about A1, A1 is basically active here first time, second time, third time, and fourth time. So corresponding to this, if we observe Y2, Y3, Y6, and Y7. So you can see here Y2, Y3, Y6, and Y7. And one can simply write here for A2. So from the truth table, again we will find out that it is here active with respect to the Y4, 5, 6, and 7. So it is not a difficult one. One can simply write these logic expression just by observing the truth table. Now the logic circuit. The logic circuit, again you can see here, if we talk about A0, then obviously depending upon the inputs, let us say Y1, Y3, Y5, and Y7. Let us say Y1, Y3, Y5, and Y7. Y1, Y3, Y5, and Y7. So you can see here we have to make, or we have to basically use a OR here. So this will be utilized like this, A0. Similarly, we will have for Y1 with Y2, Y3, Y6, and Y7. And if we talk about A2, then it will be Y4, Y5, Y6, and Y7. Y4, Y5, Y6, and Y7. And clear A or. So we hope this will give a complete idea about how one can design, or what is the basic purpose of encoder, what are its basic types. So in the next part we will have the discussion there on priority encoders and decimal to BCD encoder. Thank you.